Okay, Miranda, I'm going to give you a couple of examples of some of the problems that we did in class on Monday. If you need some more examples, send me an email. Let me know. You can use the Ask My Instructor in my math lab to show me the problem that you're having trouble with exactly, and I'll be happy to do another quick video to help with those, but hopefully this will get you off to a decent start with this stuff at least. This is the first kind of problem that we worked with on Monday. It's called a radical equation. You can tell because it's got the radical in it. Our goal is to solve for x, like with most equations, but we need to use kind of a four-step process to solve these things. And our first step is what we call isolating the radical. We want to get the square root piece of the problem on one side by itself. So in this particular problem, the first thing I want to do is move this 2 over to the other side, because that will get my square root by itself, like so. Okay? Once we've got that square root isolated, our next step is to square both sides of the equation. Okay, so we're going to take each side to the second power. Okay, now on the left side, it's really nice because the square root and the square here undo each other. So that's going to leave us with an x plus 1 over here. On the right, 7 squared is 49, right? So squaring both sides cancels out your square root, which is a really nice thing. Now the downside to this is as soon as you square both sides of an equation, checking is now no longer optional. You have to check your answer at the end to make sure that it works, because squaring both sides can mess up the signs. You can get an answer that looks right, you do all the math right, and it still doesn't work. Not the case here though. So our next step is to solve the linear equation that we wound up with for x. So this is pretty easy. We'll just subtract the 1 from both sides. Done this for a while. Wind up with x is 48. Now that is a potential answer. To see if it's actually our answer, what we need to do is we need to take it and we need to plug it back into our original question to check. That's our fourth step in the four-step process, is to plug that 48 back in for x. And see what happens. So there's my equation. I'll work this stuff out. 48 plus 1 is 49. Square root of 49 is 7. And we got a true statement there. So that checks out this time, so we know that that is a real solution to the equation. So our answer here is actually 48. And we'll call it good. So let me show you a quick example of why we have to check next. Okay, so here's another problem where we have another radical equation. This time we're a little luckier as far as the setup goes, because our first step is done for us. Our first step is to isolate the radical. The square root's by itself on one side, so that's good. Our next step is to square both sides to get rid of the square root. So that's what we're going to do. We're going to square both sides, like so, right? The square root and the square will undo each other. On the other side, negative 6 squared, negative 6 times negative 6 is 36. Okay? So again, we get a little linear equation to solve. This time we just need to divide by 3, and we've got x equals 12. So it looks like 12 is our solution to the equation. We're never done. As soon as we square both sides of the equation, checking is not optional. We have to plug it back in and see if it works. And this is an example of why. Let's do it. So if I take that 12 and I plug it in, okay, I've got an equation that looks like this, right? 3 times 12 is 36. Well, the square root of 36 is 6, right? 6 is not equal to negative 6. So we got an answer of 12. Looked like it was good. Everything we did was correct, but it's not correct. It doesn't work when we check it back in the original equation. This is called an extraneous solution, and it just happens sometimes. If you square both sides of your equation, you're going to get answers occasionally that just don't work. It's because the signs get messed up when you square both sides, not because you did anything wrong, just as part of the process. So for this particular problem, there is no real solution, is what we would say. I'm out of room, so I'll have to abbreviate there. But you get the idea. If you want to go through the 4 steps. The first step is isolate the radical. Second step is square both sides of your equation. Third step is solve your equation that you wind up. They'll wind up with being linear equations for right now. And then your last step is check your work. Checking your work is not optional, because sometimes we do everything right, we still get an answer that doesn't work. Okay, so that's the first part of the first lesson. We also talked about this thing called the Pythagorean theorem, which is a relationship between the lengths of the sides of a right triangle. You can tell this is a right triangle because it's got that little square right angle symbol. It's got to be a right triangle for this relationship to be true. And if it is, then we know that this is a true statement for the lengths of the sides of that triangle. A squared plus b squared equals c squared. Now, it's important that you're thinking about the c value as being the longest side in the hypotenuse in the triangle. It's called the hypotenuse. You can recognize it because it's the longest side. You can also recognize it because it's directly opposite from your right angle symbol. Okay? The other two, the A and the B, they don't matter which one's which very much, but it's important that you get the C, the hypotenuse, that longest side in the right spot. Okay? So I'll give you an example of how to use it next. Okay, so let's calculate the lengths of the length of the hypotenuse in this triangle. We're given the length of the two sides are 8 and 4. If we want to find the length of the third side, we're just going to plug into our Pythagorean theorem, which is this. Okay, and the 8 and the 4 that we're given are our A and our B. Our C is our hypotenuse. That's the longest side, and that's the one we don't know. So we need to make sure that this C over here is the one that we're solving for. So we don't have a value for this. That's going to be our variable. A and B, 4 and 8, doesn't really matter which one goes where, but we want to plug both of those things in. Okay, something like this. So we'll work it out. That's like 16 plus 64. So that's 80 when we add those up. And, to get the C by itself, we want to take the square root of both sides. So C is going to be the square root of 80. And now is where we need to be careful for our instructions. We can work with this a couple of ways. The most common way that we'll ask you for this answer is we'll ask for the simplified radical form. And if we do that, then it's kind of like a lesson 3 problem where we need to take that 80 and do like a prime factorization, like so. 2 goes into 20 10 times. 2 goes into 10 5 times. And because we're doing a square root, we're looking for pairs. Okay, got a couple of 2s, so 2 times 2 is 4. And then we have that 5 that didn't pair, so that's got to stay in. So 5 squared of 5 would be one solution for this. The other solution is maybe just for like an answer rounded to the nearest tenth. And if that was the case, you'd just throw that square root of 80 in your calculator and see what you wind up with. So could ask you for the answer a couple of different ways. You just want to pay attention to your instructions and make sure you're answering the question appropriately. Unfortunately, it looks like my iPad's about out of battery, so I don't know if I have time to run through a quick... I'll probably do this when I get home a little later on tonight, but hopefully that's enough to get you started with a couple of example problems from the first lesson. Again, like I said, send me an email if you have other questions, and let me know what I can do to help.